Has the deep-rooted question of whether our species is phenomenal in the universe finally been addressed? We might be moving closer to a game-changing finding thanks to the James Webb Space Telescope. Introducing K2-18b, a far-off exoplanet that has recently become a focal point in the field of astrobiology.
Why?
Its atmosphere contains a peculiarity that the James Webb Telescope discovered, which could indicate the presence of life. The molecules that make up water vapor, methane, and the exceptionally rare compound dimethyl sulfide aren't entirely random. Perhaps these are the biomarkers that have baffled scientists for so long. Does this imply that extraterrestrial life genuinely exists? Our new guardian of the galaxy, the James Webb Space Telescope, JWST, is equipped with the most cutting-edge space equipment ever developed. Its purpose is to peer into the unknown and potentially redefine our understanding of existence. The enigmatic universe of K2-18b could now be something we are prepared to explore. We rely on telescopes and other technological marvels to sharpen our understanding of the universe as we venture deeper into space, seeking answers to mysteries that have puzzled humanity for ages. Among these, the James Webb Space Telescope stands out. We owe an enormous debt of gratitude to the Hubble Space Telescope for decades of providing us with stunning, illuminating images of the universe. However, even Hubble has its limitations. Enter the James Webb Space Telescope, a mission-driven telescope that expands our understanding of the universe through the power of light. The JWST's cooling shield technology is among its most remarkable features. The size of a tennis court, this intricate technical marvel blocks heat from the sun, earth, and moon, making it far from an ordinary sunshade. Why is this so crucial? The telescope can be cooled to extremely low temperatures, making it more sensitive to faint infrared signals emitted by distant stars. Exoplanets like K2-18b can only be studied using infrared observations. Space dust can block or scatter visible light, but infrared waves can pass right through, allowing for much clearer and more detailed images. Infrared observations, made possible by JWST, are not just an achievement but a game-changer in our understanding of distant planets. What new information could we uncover? As our focus shifts to K2-18b, this rocky exoplanet, located 124 light-years away in the constellation Leo, orbits within its star's habitable zone, often called the Goldilocks zone, where temperatures are just right for liquid water to exist. K2-18b, however, is unlike other exoplanets in similar orbits. Scientifically, it is classified as a Hycean world, not your typical rocky planet. The discovery of potentially habitable worlds with an oceanic surface and a hydrogen-rich atmosphere marks a new chapter in the search for alien life. These planets offer conditions similar to Earth's hydrothermal vents, known to host diverse ecosystems. New data about K2-18b's atmosphere has been revealed by the James Webb Space Telescope's recent studies. The atmosphere of this distant planet contains various gases and elements that could support life, or at least life as we know it. These include water vapor, methane, and possibly even dimethyl sulfide. The scientific community is abuzz with excitement, theories, and hope about what these findings could mean for astrobiology and the search for extraterrestrial life. Considering its exceptional conditions, one of the most challenging and potentially rewarding aspects of exploring extraterrestrial planets is learning about their atmospheres. K2-18b's intriguing atmospheric composition and unique position in the habitable zone make it a compelling case study, showcasing how exciting and fruitful these kinds of examinations can be. Its atmosphere differs greatly from Earth's, which consists mainly of nitrogen and oxygen with trace gases. The hydrogen-dominated atmosphere of K2-18b is rich with scientific mysteries, containing trace amounts of water vapor, methane, and potentially dimethyl sulfide, DMS. Studying the atmosphere of a distant planet more than 100 light-years away is no simple task. Spectroscopy, a technique that analyzes how light from a planet's parent star interacts with its atmosphere, is used for this purpose. By examining the unique fingerprints left when molecules absorb light at different wavelengths, scientists can determine the atmosphere's composition. The James Webb Space Telescope's advanced infrared capabilities were instrumental in these discoveries. Many chemicals that were previously difficult to detect are now observable thanks to its extended wavelength range and state-of-the-art instruments. Scientists are now exploring what types of life might exist in K2-18b's atmosphere. Its abundance of methane and lack of ammonia suggest intriguing possibilities. On Earth, biological processes often produce methane, so its detection on K2-18b raises the possibility of unknown living organisms adapted to a hydrogen-rich environment. Additionally, a subsurface ocean may exist based on the planet's atmospheric composition and position, prompting questions about air-ocean interactions and their role in habitability. Could we learn anything new about habitability and extraterrestrial life from its atmosphere? Typically, Earth-like conditions come to mind when we consider life. However, evidence of life has been found on Earth in previously unimaginable places. Exploring extremophiles, organisms that thrive in harsh conditions, can shed light on potential extraterrestrial life. For example, hydrothermal vents deep in Earth's oceans emit mineral-rich, heated water, creating ecosystems that are both dark and teeming with life. Here, thermophiles and acidophiles flourish, challenging our assumptions about the conditions necessary for life. Could exoplanets like K2-18b harbor life in similar extreme environments? The unique conditions of K2-18b's hydrogen-rich atmosphere might support unknown living organisms. Methanogens, microorganisms that thrive in oxygen-deprived environments and produce methane, could potentially survive in such an atmosphere. If the methane on K2-18b is biologically produced, it opens the door to exciting possibilities. From the acidic Rio Tinto streams in Spain to the frozen Siberian tundras, the study of extremophiles broadens our understanding of conditions that can support life. The fact that life exists on Earth in so many extreme environments forces us to rethink the biological limits of life beyond Earth. As a potential exoplanet with a hydrogen-rich atmosphere and an ocean beneath its surface, K2-18b is an excellent candidate for studying extreme life forms. Perhaps this distant world harbors an entirely different kind of life, one that has evolved to thrive in its unique environment. What could the evolutionary history of extremophiles on K2-18b look like? Could complex organisms evolve from simpler ones as they did on Earth? Under the right circumstances, could a similar process occur elsewhere in the universe? These are the profound questions that drive our exploration of K2-18b and planets like it. To uncover answers, scientists rely on cutting-edge tools like the James Webb Space Telescope, which continues to exceed expectations with its unparalleled capabilities. By observing light from distant stars as it interacts with exoplanet atmospheres, the JWST is revolutionizing our ability to detect potential biomarkers and study the conditions necessary for life. If K2-18b hosts life, it would likely be vastly different from anything we know on Earth. The high levels of hydrogen, methane, and water vapor in its atmosphere point to an environment that challenges traditional concepts of habitability. However, extremophiles on Earth, such as those thriving in hydrothermal vents or highly acidic lakes, remind us that life can adapt to conditions once thought inhospitable. The next steps in studying K2-18b involve detailed atmospheric modeling and further spectroscopic analysis. Scientists aim to confirm the presence of dimethyl sulfide, DMS, a compound typically produced by biological processes on Earth. If DMS is indeed present, it would provide strong evidence of potential life. Further studies on the planet's ocean dynamics, geological activity, and atmospheric composition will be critical in determining whether K2-18b is truly habitable or simply intriguing from a chemical perspective. The discovery of DMS or other unexpected biomarkers wouldn't just expand our understanding of K2-18b, but also redefine our search for extraterrestrial life. Instead of focusing solely on Earth-like planets, we may need to broaden our horizons to include worlds with diverse atmospheric compositions and unconventional habitability models. This broader perspective could open the door to identifying a wide variety of exoplanets capable of supporting life. Planets with hydrogen-rich atmospheres, ocean worlds beneath icy crusts, or even moons orbiting gas giants may all emerge as viable candidates in the search for alien ecosystems. The tools and techniques pioneered by the James Webb Space Telescope will play a crucial role in exploring these possibilities. The implications of finding life on K2-18b, or any other exoplanet, are profound. Such a discovery wouldn't just answer the age-old question of whether we are alone in the universe, it would also compel us to rethink our place within it. The realization that life can thrive in vastly different conditions would expand our understanding of biology, evolution, and the resilience of life itself. Furthermore, the confirmation of extraterrestrial life would have philosophical, cultural, and even practical implications. It could inspire a new era of scientific collaboration and innovation as humanity unites in its quest to understand and communicate with life beyond Earth. Such a discovery would transform our worldview, forcing us to confront questions about the nature of life, our role in the cosmos, and the boundaries of human understanding. Philosophically, it would challenge anthropocentric perspectives, reinforcing the idea that Earth is not unique but part of a vast, interconnected cosmic ecosystem. Culturally, the confirmation of extraterrestrial life could lead to profound shifts in art, literature, religion, and global identity. Humanity might see itself not just as citizens of Earth, but as participants in a greater universal narrative. Religious and spiritual beliefs could adapt or evolve, incorporating new understandings of creation and existence. Practically, the discovery of alien life might lead to breakthroughs in technology and science. New bio-inspired technologies could emerge from studying alien ecosystems. Understanding how life adapts to extreme conditions could influence innovations in medicine, climate science, and even space travel. For instance, mechanisms used by extremophiles to survive harsh environments could inspire solutions to Earth's environmental challenges or aid in the development of long-duration space habitats. The implications also extend into ethical realms. If intelligent extraterrestrial life were discovered, questions about communication, diplomacy, and mutual respect would arise. How would we establish contact? What rights would such beings have, and how would we ensure their protection? For now, the focus remains on K2-18b and planets like it. The journey to confirm the presence of life is far from over. Future missions, such as the planned Habitable Worlds Observatory and other next-generation telescopes, will build on the findings of the James Webb Space Telescope. These instruments will allow for even more detailed analyses of exoplanet atmospheres and environments, bringing us closer to answering the question of whether we are alone. K2-18b may only be the beginning of a new era in astrobiology. As our technological capabilities expand, so too does the potential for groundbreaking discoveries. The universe is vast, and its mysteries are endless. By continuing to explore and question, humanity is not just searching for life elsewhere, we are redefining what it means to exist.